Okay, so today we're going to be learning adding and subtracting rational expressions. So a rational expression, it's quite simple. It's basically just like a fraction, just with a x or x squared or any variable, I guess you could say, whether it's an a or a b or a c, you get the point. It's just a fraction with that thrown in. So to solve each of these, I'm gonna teach you how to solve a couple problems. So to start out, we're going to do a very simple one. So we're going to do 5 over 2a plus 3 plus 3a over 2a plus 3. And because the denominators are the same, we don't need to do too much to the equation. We need to put the whole equation over 2a plus 3. And then we're going to do 5 plus 3a. And this is our most simplified version of the equation. Next, we're going to do a little bit harder example. Okay, so we have 5 over x squared minus 36 minus 9 over x squared plus 5x minus 6. So to start out, we need to factor each denominator. So we're going to have x plus 6 and x minus 6. And if you don't know whether or not your factors are right, you can go into y equals, and first you'd enter in y1 x squared minus 36, and then in y2 you'd enter what you think is the factored version, so x squared plus 6 and x minus 6. And if the graphs overlap, if you only see one graph, I guess you could say, then you know that you have the right factors. So next, our next factor for this, if you did the box method, okay, so this is multiply and this is add, and because if this is a and c, so you multiply, x squared is a and negative 6 is c, so we're gonna whatever multiplies to equal, or a times c multiplies, so here you go, we're going to put a times c equals negative 6, and then b goes here, so b is x, so we need to find what multiplies to equal negative 6 and adds to equal 5, so that'd be 6 and negative 1 and 6 and negative 1. So now we can enter this into our box. So a goes here and c goes here. Or a goes where the 1 is and c goes where the 6 is. So next we're going to enter what we got for b. So 6 and negative 1. Sorry if this is a little small and hard to read, but since you tried to find the common multiple of all boxes, so x is going to be our first one. It would technically be 1, but 1x is the same as x, and then plus 6 is our common multiple for this. This is supposed to be a negative sign there for the negative 6, and then this is going to be x again, and then negative 1. Okay, so now we know our factored version of this is x plus 6 and x minus 1. Okay, and we're going to erase this over here to give you some more room, but you should already know how to factor. I shouldn't need to tell you how, but just in case, that's kind of a quick summary on how I like to do it. Okay, so next we're going to set up our factored expressions. So we have 5 over x squared minus 36, we're doing our factored versions here, so x plus 6 and x minus 6, and then minus 9 over x plus 6 and x minus 1. Okay, so now we need to find out what do we do to make the denominators equal to each other. Well, if we put x minus 1 here, or x plus 1, no, x minus 1. Here, we'll go back. X minus 1 there, and then x minus 6 here, we get, our denominators become the same. Okay, so we're going to write out our new denominators. Okay, so we're going to write out our new expression for each side. So 5x minus 1, and then x plus 6, x minus 6, x minus 1, and then it's going to be the same thing for the other side, or the denominator is going to be the same thing for the other side. So x minus 6, 9x minus 6, and then x minus 1, x plus 6, and x, sorry, my foot just fell asleep and it really hurts. Okay, and x minus, okay, x minus 6. Okay, so now we're going to find our simplified version of this equation, and so we're going to erase all this, and we're going to do our simplified version of the equation to get our final answer. Okay, so we know we had, again, we have to rewrite all this, 5x minus 1, x plus 6, x minus 6, x minus 1, and then minus 9, x minus 6 over x minus 1, x plus 6, x minus 6. So our denominators are the same now as we went over, and so we're going to have 5x minus 5 minus 9x minus 54, I'm pretty sure. Let me double check. Second function. Yes, 9x or negative 54. Okay. So our denominator, now that it's all the same, we don't need to write our denominator twice. Praise Jesus. X plus 6, x minus 6, and x minus 1. Okay, so now we need to simplify the top. Okay, so negative, or 5 minus 9 is negative 4, I'm pretty sure. Hold on. Yes, it's negative 4. So we have negative 4x, and then we have 3 negatives here, and a negative plus a negative makes a that means we're gonna add, but then we have another negative, so we're gonna subtract. But because there's 3 negatives, that makes it positive, so we're gonna have 49 over, here we go once again, x plus 6, and then x minus 6, and x minus 1. Okay, so this is our simplified version of this equation. Raise the roof. We are done with this problem. Okay, so now we're going to do a problem where we have to factor both sides again, but this time we're going to be adding when the last time we were subtracting. So Okay, so in our new problem, we're going to be adding this time, whereas last time we are subtracting. We have x over x squared plus 5x plus 6 plus 2 over x squared plus 3x plus 2. So next we're going to write our new factored form of each side. So the left side is going to be x plus 2, x plus 3, and then plus 2, x plus 2, x plus 1. There's a lot of pluses in this one. Okay, so we gotta multiply each side so that way our denominators are the same. So what is this side missing? Well, this side is missing x plus 3, so we're going to multiply the right side by x plus 3. And then next, the left side, what's the left side missing? The left side is missing x plus 1. Okay, so we're going to erase all this. Okay, so now we're going to find out what each side equals now that we've multiplied both sides. So we're going to have x squared plus x over x plus 2, x plus 3 times x plus 1, and then we're going to have plus 2 x plus 3 over x plus 2 times x plus 1 times x plus 3. Okay, so now we are going to simplify this. So if we add all the numerators together, we get x squared plus 3x plus 3 over x squared plus, or x, not x squared, x plus 2 times x plus 3 times x plus 1. And again, because our denominators are the same, we just take the bottom or our denominators and put that at the bottom of our new expression. Thank you for watching. And again, this was adding and subtracting rational expressions.